cool. Okay, let us begin. So like I said, we are learning how to use our resource sheet. In particular, we're learning how to identify the cations today. So there's cations and anions. You will need to be able to identify both of them. While you're doing that identification process, you should be recording the different experimental steps you are doing. You should be recording your observations, and if there's any precipitations that have formed, you should be recording what that is as well. So there's this first side of the sheet. If you just answer this first side of the sheet, you'll have enough to get an achieved because I can walk you through the steps. It's all about the identification process. If you're aiming for merit or excellence, that is on the back side of the sheet, and in that case, you need to justify your identification and, if relevant, any equations that are occurring. So I will walk you guys through both of those. I will probably just start with the achieved. We'll see how we go. We'll practice doing that, and then we can look at the merit and excellence if we have time today and if you guys are feeling ready. Are we good so far? Cool. Okay, so we'll say that the name for this one, we'll just write teacher example 1. And just so you guys are aware, I do have a color code whenever I'm writing my answers to help you guys keep track of what your requirements are. So if I write something in red, that is stuff that is required for the achieved. If I write something in blue, that is requirements for the merit. And if I write anything in green, those are the requirements for excellence. Why am I doing that? I meant to write green. So really useful kind of thing, so that way we can keep track of what we need to do. I'm just going to grab my checklist to make sure that I've covered everything we need for the achieved. All right, so first things first, for my anion identification, I need to make sure I have a box of all the things I will need. I will give you guys these boxes so you don't have to stress about finding things, but we need to make the boxes first. So when it comes to making these boxes, I'm going to grab some ice cream containers. So in an ice cream container, if I look at my flow chart and I look at the steps that are required there, the first thing I need is the red litmus paper. So I'm going to put that into my box. Be mindful I have different colored litmus papers out at the moment, so the only one you want are the red ones. We're good so far? All right, the second thing I will need in my box is a solution of barium nitrate, which I have at the front. Grabbing that. If I continue going down that pathway, I see that I have a step here to add silver nitrate, so I'm going to grab that. And put it in my box. Then if I keep going down, it just says no precipitate, and that's the end of that line. So let's look what happens when I go to the right here. I need to have some ammonia. We've got a bottle of ammonia. And there's one more thing I forgot to add. I'll go grab it. And that is going on this line here. That is dilute hydrochloric acid. So those are the 1, 2, 3, 4, 5 things I need in my box. Yep. So these are the reagents I need to test for an anion. Other things I will need will be test tubes. That way I can do that reaction. Just grabbing a handful. And I will need a test tube rack to make my life easier. For the litmus paper, I don't want to be shoving litmus paper down my test tube and then having to get it out. So I'm grabbing a paper towel so I can drop my unknown solution on there. And let me grab my unknown solution as well. In fact, why not have see how the process works. All right, so go over to my desk so you can see what's going to happen. All right, so first step that I have when I'm looking at my flow chart is I need to take my unknown solution and add red litmus. So I'm going to write that down as my experimental step number 1. Here, do you guys want to know what the unknown solution is now, or do you want to know at the end? Doesn't really matter because right now you are learning it. I'll just tell you. All right. Actually, no, I'll pretend like it's unknown and then we'll confirm it. All right. So here's my unknown solution. So step number 1, I would say I take my unknown and add it to red litmus. So I'm writing down my first step to get an idea of what's going on. I don't want to be shoving red litmus down my test tube, so what I've done is I've grabbed a paper towel. I'm going to grab a small piece of the red litmus that is cut. And what I want to see is, does it change colors? Depending on whether or not it changes colors, I then go down the pathway that corresponds. There we go. We've absorbed it. See any color change? No. So, since I don't see a color change, you see how there is 2 choices? I can either go down or I can go to the right. I would go to the right if it turned blue. If it turned red, I'm going down. So, or sorry, if it remained red. So in my observations, I would state that it remained red. Are you okay with that so far? All right. So then, once again, I follow my flow chart. You will be given this on the assessment, and then I do my step number 2. So if it remains red, I have a possibility of 4 different types of ions. I could have, or sorry, I should say anions. I could have a sulfate, I could have a chloride, I could have an iodide, or I can have a nitrate. So I get a new sample, and in this case, I am testing it with my barium nitrate. So now I'll start moving to test tubes. I will add my unknown, and you just need a couple drops, like that. And then I'm going to grab my barium nitrate out of my box. Here's my barium nitrate, and I'm going to add a couple drops there to see what happens color change wise. Before we do it, let's write down what our step is. So we have our unknown. And we added barium nitrate. Now you have a choice in how you write it. I'm not fussed. You can write the word barium nitrate, and the bottles do have it named. So always look at the bottles if you're not sure. You could also write the formula as well, and that matches what is on the flow chart as well. So I'm happy either or with whatever you want to write. In case we want to have both. Again, I have 2 choices, so what am I looking for based off the flow chart? A white precipitate or no precipitate. So we'll have that. I added a good squirt. Anything? No. So no precipitate, remained colorless solution. I'm happy if you guys want to abbreviate precipitate as PPT, because precipitate is a very long word to write. All right, do we know what it is yet? No, gotta keep going. So again, we look at our flow chart. If there was no precipitate, I go down this way. I basically ruled out sulfate as one of my options. I need to get, again, a new sample. So that means a new test tube. And with that new test tube, I will put my unknown solution in there. And I'm going to put silver nitrate in there instead. So again, let's write down our steps. We take our unknown. And added, if we're not sure what that AG formula is, we can always grab the bottle and we can see that says silver nitrate. Again, I'm happy if you want to write the word or if you want to write the formula. I'm just writing both so that way we can get used to the chemistry language. Cool. Keep going. All right, so I have my new test tube. I'm taking my unknown solution, adding a couple drops in there. Then I take my silver nitrate, and what I'm looking for is any precipitation. I'll move that paper away so you can have a better look. So we see a precipitation this time. All right, again, observations. So it's kind of like a cloudy white precipitate forms. That's what I would describe it. We're still going down the rabbit hole because I still don't know what it is. But with that information, I've now narrowed it down to two choices, either chloride or iodide. So I can get somewhat of a hint from it because I see that it has one that says white precipitate and one that says yellow precipitate. But from experience, the yellow and the white look quite similar. So we're not going to just use that as our only deciding factor. What we're also going to do is add excess ammonia to the solution. This here is a new step, so I'm going to write that down. It doesn't say new sample, so I'm adding it to the test tube that's already there. So we're going to add excess ammonia. And if we're not sure what ammonia is, again, we can look at our bottles. I'm just trying to find my ammonia bottle. There it is. All the bottles are labeled in both the formulaic and the word version. Now, when we see the word excess, we mean add a lot of it. Add a lot and see what happens. Again, I have two choices. Either my precipitate disappears or it remains. So what I'm going to do is I'm going to move this sheet out of the way. I'm going to get my test tube. And I'm putting it against my dark teacher desk background so that way it's easier. But I'm going to add quite a generous squirt. It may not disappear because my ammonia is not going to be terribly strong. I might need to take some of it out. But we can see at the top that it's starting to disappear, right? So in this case, if I'm not 100% sure, what I can do is I can take some of this out and add it to another test tube. So I'm going to grab myself a little pipette, because sometimes it's all about getting the ratios right. So these pipettes can be quite useful in helping me determine whether or not my precipitate has disappeared. I might be able to use it to help me mix it a little bit better. The other thing I can do is I can take some of it and add it to a new test tube. So that way my ratios are a little bit better. It's always worth double and triple checking things. So I can see here that that's still a cloudy solution. I want to make sure it's going to go away. And we see how by doing that, I've been able to confirm it is disappearing. Do we need to see it again? We're good. We're good? Okay. So, when I added that excess ammonia, I realized that my white precipitate disappeared. And that's my final observation. Now, like I said, let's finish up the achieve stuff. So, first thing I need to do when I'm looking at my checklist is I can identify an unknown ionic compound by carrying out an experiment. So we need to figure out both the anion and the cation. We were just focusing on the anion today. Based off the steps that I've done, I've ended up here. So I've identified my ion as the chloride ion, Cl minus. So that's the first thing I need to do for my achieved. I'll just tick it off to show you. Second thing I need to do for an achieved is I need to state all my observations. These are my observations. Each one of those steps that I've done, I have stated what I see. So I can tick that one off. I've also shown my steps on how I figured out it was chloride with my experimental steps. Are we good so far? All right. Next thing is I need to identify the precipitate. So any precipitate that has happened, I need to identify. So if I'm looking at my observations, the third step is the only one that I have a precipitate. So I need to figure out what that precipitate is. Now, since I'm identifying the anion, what I want to check is what cation I added. So we see here, and I'm just going to write this in yellow just to kind of show my processing. So when I look at my step with the white precipitate, I added silver nitrate. We have Ag plus and we have NO3 minus as my two ions that are there. Whenever I form an ionic compound, I need a positive and a negative. Since I'm identifying the negatives, I can ignore the nitrate, and I know silver must be the important ion in that case. So when I go to identify it, I'm going to write down silver chloride. That's what has formed. Now, in this case, I suggest you write down the word and the symbolic equation, because if you make a mistake on the symbolic equation, I have to mark it as incorrect. If you have the word equation there as, the word version as backup, I can still mark you as achieved. So that's AgCl. But like I said, if you make a mistake, it's best to have the word equation there as backup. And that's all you need to do for the achieved. Questions, concerns, comments. I should say not all you can do. There's one more step, but we'll talk about that later. So identify all the precipitates. In this case, there was only one precipitate for me to identify. The last thing that we need to do for achieved is we need to describe the significance of the ion on humans and environments. In that case, it's just a little write-up, kind of short paragraph, but we'll do that at the very, very end once you've identified all your ions. Okay? And that's all you got to do. Questions, concerns, comments? None? All right, you guys ready to give it a go? All right, so I'm happy for you guys to work in groups. I will grab, and do you guys want to know what the ion is so you can make sure you know you're using the flowchart correctly first? Or you guys want me to just put one in a beaker and you can try to figure it out? I see Xavier just nodding his head like, yes, just give me an unknown and I can try to figure it out. Okay, you guys can have it that way. All right, so while you guys are doing that, just be mindful you need to set up your prep station. So inside your box, we need to have the red litmus, the barium nitrate, the hydrochloric acid, the sodium chloride, what else do you need? Ammonia, and silver nitrate. Sorry, you don't need sodium chloride. That was the unknown, which is confirmed because we have the chloride. All right. We will need goggles. Make sure your hair is tied up and out of the way. You will also need test tubes and a test tube rack. And then cleanup's very simple. You just rinse and put things back. I'll put out a beaker for us to clean up the pipettes as well so we can reuse them. All right. I'll give you guys another sheet too, so that way you can write that one out. So you can say practice number 1. All right. Like I said, this first half of the sheet is mainly just the achieve requirements. You're talking about your experimental procedure, you're talking about your observations, and you're identifying any precipitates. When we are trying to get to merit and excellence, I then need to do some extra things. The first thing is I need to link my observations and explain my process in my identification. So this sheet goes in parallel with what you have written. So for step number 1, I have taken my unknown solution and I noticed that when I add it to red litmus paper, it remained red. So if I was thinking about justifications to that, with litmus paper, what is it supposed to do? Do you guys remember? It's supposed to tell us pH. So if we look here at our list, there's hydroxide and carbonate. Both of those are basic anions, whereas the sulfate, chloride, iodide, and nitrate are all not basic ions. So that's what that first step is telling me, and that's what my observation is. So if I want to justify that observation, I would say it remains red because the anion is not a base. What I could also do is list out what it could be. So when I look at my flow chart, there are 4 possible choices. So it could be SO4 2-, it could be Cl, it could be I-, or it could be NO3-. At this point, I am not sure, but it does help me narrow it down. We good? All right. Then when I look at step number 2, I added an unknown and I added barium nitrate and no precipitate formed. It remained a colorless solution. So when I'm looking at this here, if a precipitated formed, it would have told me that I would have barium sulfate. But since sulfate is not present, I don't have any precipitates. So again, what is our justification? So no white PPT formed, so it is not SO4 2-. If it was SO4 2-, barium sulfate would have been made, and based off of solubility rules, it would be my white precipitate. So I'm just justifying what I see. So what that then tells me is that it could be iodide, chloride, or nitrate. And just for the record, I don't know if I made it clear, I'm doing the example that I did at the beginning, which we know is chloride. All right, step number 3, when I did my chloride identification, I got a white precipitate. So now I need to justify what that white precipitate is. So we had a white PPT form. And if we then link in our solubility rules, we can see that most halides are soluble except for those with silver and lead. So I can then justify why that white precipitate formed. So silver and halide, such as chloride or iodide, is insoluble. all can't be nitrate. Because all nitrates are soluble. So it could be the chloride or iodide. You see how I'm justifying each step? I'm using that flow chart and I'm using my solubility rules. So I'm using this one right here. Most halides are soluble. Remember, those halides are anything in group 17. We're good so far? All right. And then step number 4, I added excess ammonia and that white precipitate disappeared. This justification is actually up to the excellence level, so explaining why. So the reason why that white precipitate disappears is because a complex ion forms, and those are soluble again. Now, when we look at the list, I have provided here our list of complex ions. So we know we have the silver one, which is this guy here. So that tells me that's what the complex ion is. I can see nothing else there. Now, complex ions can form with the chloride, but not with the iodide. Basically what happens is if I have enough ammonia, it can knock out the chloride. It can't knock out the iodide. And I'll show you guys the equation so you can understand what I mean. But that is now looking at the excellence level work. Just mindful of the time. All right, can I keep going? All right. So, when I'm looking at that merit requirement, can I link my observations and explain the process? That is what that backside is doing. So I've ticked that off. Oops, sorry, that's the achieve requirements. That's the merit requirements. The next thing I need to do is explain my results using solubility rules. Have I done that in my justifications? Yes, I have, so I can tick that off. The next thing I need to do is balance my equations. So I find the easiest way for me to balance the equations to make my life easy and not to make silly mistakes is to identify the precipitate and then work backwards. So when I identify silver chloride as my precipitate in step number 3, what I would do is I would draw my arrow, I would draw AgCl, show it as the solid, and then break it back into its ions to show that I'm adding those two together. Like that. That's the easiest way to do it. So that way you don't accidentally include ions that you don't need. Are we okay so far? All right. The other the other equation I have is this complex ion. The good news is that I provide this as listed on my resource sheet. So what I do is I take the silver and I write my product down. With the complex ions, we need to have the square brackets to show that it's soluble. And I need to show the positive sign and that it's aqueous. Again, when I have that product, I can just write it as what the reactants are. So I had Ag plus, which is aqueous, plus the ammonia. Now ammonia, NH3, I see there's a 2 underneath here, so I'm putting a 2 in front to balance it. It's going to zoom up so you guys can see that. So with that complex ion forming, the reason why it's able to do that is by adding a lot of ammonia, what I can do is I can shove off the chloride and thus get rid of the precipitate. So let me just underline the chloride there. I can shove it off and make the complex ion. If I had silver iodide, which was that yellowish color, the complex ion never formed because it cannot displace it. So it's stuck as the precipitate. So we never saw it dissolve. So that's how we can use it as a distinguishing step between the chloride and the iodide. All right, when we are looking at our checklist, the merit requirement is balancing all the equations. Those are my two equations there. For the excellence, we need to justify why that precipitate disappears, and that is that justification here with the complex ion. So this is the only thing you needed for the excellence. So unfortunately, with a lot of the chemistry standards, the merit step is a big jump, but the excellence step is a very small jump. So you might as well try for the excellence if you're already there. And that's what you need to do for the write-up. All right, I'm just mindful of the time because I know we're almost there. Make sure you wash your hands if you haven't done so already, soap and water. For your homework tonight, you guys have done 2 identifications today in class. You did the unknown number 1, which is the iodide, and you also did unknown number 2, which is the sulfate. Those are the answers to what you guys should have found. What I want you guys to do is finish the write-ups for me for homework. So making sure this is all completed, and if you're aiming for the merit or excellence, making sure you're doing this write-up as well. Okay? Do I see you guys tomorrow? I think I do. Or is it? No, I see you guys on a Wednesday. Do you guys want to see the cation ions and just keep on practicing this? Or you guys wanting just to do the anions still? You guys ready to move on to cation ions? You can do both as practice. It's the same setup. Okay.